Today's lesson deals with finding angle measures in polygons. Not only are we going to find angle measures inside polygons, but we're going to talk about angle measures outside too. So first off, whenever we're talking about diagonals, we can talk about them in two different ways. If we have two pentagons, there are two different scenarios that we should be able to consider. A diagonal drawn from only one vertex, or diagonals drawn from all vertices. So this first one's pretty easy. So first off, what is a diagonal? How would you describe a diagonal? Going from one vertex to an opposite vertex, the one not right next to it, so a non-adjacent vertex. Is that the only diagonal I can draw from that vertex? No, I can draw one more. There are two vertices. However, when you're drawing them from all vertices, I can go over here, and you can see how I can keep doing this. And there are all my diagonals. How many diagonals are there on this picture? Two diagonals. How many are on this picture? Count.
10.
More than 5? There are 10. 2 coming from each vertex. Actually, there aren't 10. I'll highlight them. 1, 2, 3, 4. It is 5. Good job if you said 5. Yeah, I double counted them for some reason. Now the other thing that is interesting about this is this relates how you find the sum of the interior angles. Do you all remember what the sum of the interior angles were for a triangle?
180.
180. I'll go ahead and tell you the one, or do you all know the one for quadrilateral? 360. All right, now we're at a pentagon though. It's bigger, it's 540. What do you notice about these? Increasing by how many? 180. Here's why. 1 triangle, 2 triangles, 3 triangles. So what's 3 times 180? 540. What's 2 times 180? 360. What's 1 times 180? 180. So that's where it comes from, and here's a formula for that. So n minus 2 times 180. What's this n stand for? It stands for the number of sides. So how many sides do I have on a 4-sided shape? 4, obviously. 4 minus 2 times 180 gives me 360. 5 minus 2 times 180 gives me 540. And so on. You can do this for large shapes, and you'll just keep getting larger and larger numbers. Next thing we got to talk about is a corollary to this theorem. Corollary is just another theorem related to that one up there. The sum of the measures of the interior angles of a quadrilateral is, yeah, we just talked about that, 360. So go ahead and write that down. So basically, it's just wanting to tell you something that you should know. You should know that a triangle interior sum is 180, and that a quadrilateral interior sum is 360. The others, if you know them, it's helpful. It may speed things up, but I'm not going to make you memorize other ones. These two, you should know. We're going to get more detailed with them a little bit later. While we have this view, let's look at example 1. Find the sum of the measures of the interior angles of a convex hexagon. Hex means how many sides? 6. Okay, so we have a 6-sided shape. What is that formula for the sum of the interior angles? Well, the formula is n minus 2 times 180, and this is one we're going to write a lot today, so you should kind of have it memorized by the end of class. N is the number of sides, so that's 6 minus 2, and then times 180. 6 minus 2 is 4. 4 times 180 is, pretty sure it's 720. So once again, I'm going to remind you of an important formula. To find the sum of the interior angles, we have a formula. Does anybody remember it from the other page? N minus 2, and that's in parentheses, times 180. If we do n minus 2 times 180, we get the sum of the interior angles. So these are key words to look for. Anytime it wants the total of all the angles inside a shape, we're going to use this formula. Let's see what it asks for here. The sum of the measures, there's that sum, of the interior angles of a convex polygon is this. What do I do with that number? Well, we're supposed to put the sum right here, or get the sum, and it goes right here. They just gave me the sum, so where should I put that? Right there, after the equals. We're trying to find the number of sides. That's what it's asking for. Classify by the number of sides. So how do we do that now? Divide by 180 is one way to do it. Do that first. The whole thing right here is being multiplied by 180, so dividing would get rid of that 180. They'd cancel. So I'd be left with n minus 2 equals this part over here. So type in your calculator, 1260 divided by 180. What do you get there? 7. The last part's pretty easy. Add 2. Classify the polygon by the number of sides. What's a 9-sided shape called? Nonagon. Write that down. That's a nonagon. So since we know the word for it, we're going to say it. Once again, what's in a 50-sided shape called? Sometimes a 50-sided shape, we'll just call it a 50gon. That generic little ending. What's an n-sided shape called? N-gon. This is a good little topic for a quiz or test. Alright, up next, find the value of x in the diagram. What kind of shape do we have right here? How many sides do we have? 4. A 4-sided shape is a quadrilateral. And this is one that you should know its sum right off the bat. 360. So the sum of the interior angles is 360. That's one you should know. You shouldn't have to do the n minus 2 180 times 180, but you can if you need to. 4 minus 2 is 2. 2 times 180 is 360. So I know the sum is 360, and I know a few of them in here. I'm just missing one. How am I going to use this number and what's on the picture to find that one little piece? Okay, so you could add up all the given ones and set them equal to 360. Since we're only missing one, though, I can just do 360 minus what is given. That's pretty fast. So all you got to do is type that part in the calculator and see what you get. So when we subtract all these numbers from 360, we get 42 degrees. So we can say x is 42. Once again, I would use this method if I was missing more than one angle. If I'm only missing one angle, I'd just use 360 minus, and I'd be fine there. All right, we now have 3 checkpoints. I'll give you a little bit of time. Try these out. They mirror our examples. On this first checkpoint, it says find the sum of the measures of the interior angles. Once again, some key words. We have sum, we have interior, and we have decagon. If you remember, we had a little formula for the sum of the interior angles. What was that formula? N minus 2 times 180. Our n is 10. So 10 minus 2 times 180. N minus 2 times 180. So 10 minus 2 is 8. I would type in 8 times 180. And what do you get? 1,440. That's good. Up next, we have these 2 checkpoints. Oops. Didn't like that. Let's try these. All right, there we go. So it says the sum of the measures of the interior angles is 1,620 degrees. Find the number of sides. Classify by the number of sides. What do we do in this case? Well, we got to set up the formula first. Good. N minus 2 times 180 equals that big sum. That big sum always goes to the right. We'll divide by 180. So those cancel. What do we get over here on the right? 9. How do you get n alone? Add 2. Easy. And once again, 11-sided shape, I would take 11 gone right now. And we'll tell, how do you spell that? Hexagon. I think, yeah, that sounds familiar. I'm not going to make you memorize that one, though. It's an oddball. Hexagon. Number 3, use the diagram at the right to find measure of K, measure of angle L. What do you notice about angle K and angle L? They're congruent. So if I call this one X, this one is X also. They're the same. But they're all inside a triangle. So let's start off with our inside sum formula. So n minus 2 times 180. What's the number of sides? 5. 5 minus 2 is 3. 3 times 180 is 540. So we did that in our head. We could have used this formula. We did that one in our head. When they're lower numbers, it's not hard. So 540 is the total of all this. So that means that 68 plus 105 plus 109 plus X plus the other X will total up to be 540. From there we can combine like terms. These are like terms. I can just add all those. When you add all those, what do you get? 282. And when I add these two, I get 2x. So that means we now have 2 steps remaining. How do we get x alone? Subtract 282 first, and then divide by 2. When you subtract 282, you get, what, 250, what is it? 258, yeah. Dividing by 2 will give you 129. All right, on Theorem 8.2, things change a little bit. We go from talking about interior angles to talking about exterior angles. So notice, typically our interior angles are right here where I place this little blue dot. But now we're doing the one right next to it. That's an exterior angle. What do you notice about these relationships right here between these two? Ah, nice. These are supplementary. They're a linear pair. That's why they are supplementary. So if I put another angle here, these two would be supplementary. That's a good thing. Sometimes it'll give you a picture like this, though. And they will have this drawn. And if I say these letters, if I drew that picture and I gave you this question, name me an exterior angle. Who could give me an exterior angle from that picture? All right, go ahead. What do you think? A, B, D is correct. Can anybody give me another angle? Yes. CBA is incorrect. This one is not good. EBC is correct. Why is this one right here incorrect? Not an exterior. It's outside, but why is that? Because it's vertical to the inside. We never talk about the one that's vertical to the inside because that's just like talking about an interior angle. So it doesn't do us any good. We want the one that's right adjacent to it. You could have picked either one of these and you would have been good. The only wrong one is the vertical one to the interior angle. So that's just a little side note. All right, back to exterior angle theorem. The cool thing about this one is it's really easy to remember. The sum of the exterior angles is always 360. It never changes. If you have a shape with 3 sides, its exterior angles are going to add up to be what? 360. If you have a shape with 100 sides, its exterior angle sum is 3. If you have a shape with 1,000,000 sides, its exterior sum is 360. It is always going to be 360 for the sum of the exterior. So I can kind of prove that to you real quick. Look at this. If I highlight this one, I'll highlight this one. I'll highlight all these angles real quick. Now I can grab all those angles and pull them out to the side. Say I want to add this one plus that one. So adding is putting together. So I'm just putting these angles together. I want to put this one with it. And I want to put that one with it. Well, what do you notice? Well, you should notice that here's one of the angles. There's the next one. There's the next one. There's the next one. There's the next one. And I added up to a full circle. And a circle is always 360. Now, how would this change if I had that million-sided shape? Yeah, you'd have a ton of really small angles. So it'd start looking like this. And the pen can't even keep up. I'm drawing so many. So a million-sided shape would have so many little tiny angles, but you would still maintain that circle. You would still maintain that fact that the exterior angles add up to 360. So make sure to get that. Once again, the sum is 360, the sum is 360, and that is a fact that it always will hold true. Are these angles interior or exterior? These are exterior on this example. They're saying solve for the value of x. All you have to do is realize that if you add all those up, they always will add up to 360. So x plus 88 plus 2x plus 89, my bad, plus 85, and you'll get 360. Combining like terms is hard for some people. Whenever you're combining like terms on one side, so we're just on this side, the equals, we just do what the signs say on that side. X plus 2x is 3x. 89 plus 85 is 174, and then we have that 360. Now the last step, it wants you to do two things in one. It wants you to subtract the 174 and then divide by 3. When you do that, what do you get? Is it 60 or 62? 62. All right, here's another interesting problem. On this one it says the base of a lamp is the shape of a regular 15-gon. Those are some key words. Regular 15-gon. I would underline those. Find the measure of each interior angle. So we want each interior angle, and we want each exterior angle. So you got to remember back. What does the word regular mean? All angles are the same, and all sides are the same. So that means it's a nice symmetrical picture. Now, we've talked about the sum of interior and the sum of exterior. How do you find the sum of interior? That should help us on part A. N minus 2 times 180. That's going to give us the sum of the exterior. Well, we already know N. N is 15, so I'll change that real quick. My calculator, I would type in 13 times 180. Tell me what you get for that. 2,340. That's the sum of all the inside angles on a 15-gon. However, I don't want the whole sum. I want each. That means I want only one. But it's a regular shape. Yeah. At the end, all you got to do is take that big sum, that 2,340, and divide it by 15. Why do we divide it by 15? Because there are 15 angles inside. We only want one. They're all the same. Divide by 15, and you get 156. So there's part A. Done. Part B wants one exterior angle. One exterior angle. Well, what did we learn about exterior earlier? 360. They add up to 360. But how many exterior angles are there? 15. So what do we get? What do we get? 24. If you remember, I told you a trick earlier. We had a shape, we had an interior angle, and then we had an exterior one right beside it. And I said, how are these two related? You told me they're supplementary. Well, are they supplementary? Yeah, they add to 180. So that means we've done it right for each interior and each exterior angle. All right, we now have 2 checkpoints left. See what you can do on these. Here are the solutions to the last part. Remember that for the exterior angles, they're always going to sum to 360. So here are the other pieces involved. We have 5 angles, so we're going to have 5 things added together. Add these up, combining like terms to get 287. Subtract 287, we get 73. The last part, interior angle sum is 1,260. Since it's regular, I can divide by the number of sides to get how much each interior angle is. I can also figure out the sum of the interior angles, or exterior angles is 360, divide by 9, and you get 40.